Hi, my name is Erica Warkus, and I'm carrying out my MD-PhD research at the University of Hawaii John A. Burns School of Medicine. Our research focuses on studying the effects of chemicals on the earliest stages of mammalian development using an in vitro model system. Many chemicals that we encounter in our day-to-day lives have the potential to disrupt human development, resulting in birth defects or even fetal death. The majority of physical birth defects are caused during the first 3 to 8 weeks of development during the processes of gastrulation and organogenesis. Gastrulation is the process of cellular migration and differentiation that creates 3 embryonic germ layers. Once these germ layers form, the internal organs begin to develop. Since all of this happens when the embryo is only a little larger than your thumbnail, it is very difficult to study the effects of chemicals that cause birth defects in mammalian pregnancies. Currently, the FDA requires that new medications undergo many rounds of developmental toxicity testing in vivo using live lab animals. As a result, developmental toxicity testing has some of the highest rates of live animal usage in research. Therefore, there is substantial interest in the development of in vitro teratogen screening assays able to easily and accurately identify developmental toxicants. One of the most promising in vitro methods to detect teratogens is the embryonic stem cell test, or EST. This test measures the ability of stem cells to survive and differentiate into functional cardiomyocytes. This, and subsequent variations of the EST, look at specific embryonic cell types, such as neurons, osteoblasts, and cardiomyocytes, and assess the impact of drug treatments to identify any potential teratogenic effects. Instead of focusing on a single cell lineage, our lab's research looks at the effects of chemical exposures on early embryonic morphogenesis as a whole. During gastrulation and organogenesis, the embryonic cells collaboratively establish body axes and direct cellular migration and interactions. The most common birth defects are the result of genetic or environmental disruptions in this process of embryonic morphogenesis. To model in vivo effects, a teratogen screening assay should evaluate adverse impacts on embryonic body patterning and morphogenesis, in addition to assessing cell survival and differentiation. In my research, I make cellular aggregates called embryoid bodies, each of which starts as a small clump of about 200 cells in a droplet hanging from the lid of a petri dish. Over the course of 4 days, the cells making up each embryoid body organize, differentiate, and establish a craniocaudal axis before elongating in a way that very closely resembles the process of embryonic morphogenesis. When treated with a chemical capable of disrupting embryonic development, the embryoid bodies show abnormal growth and elongation. By looking at the comprehensive process of morphogenesis, we are able to investigate the effects of developmental toxicants at the earliest stages of embryonic development. We hope that this assay will complement the EST and other in vitro screening assays in order to significantly reduce the number of animals sacrificed for developmental toxicity testing in the U.S., and we are very grateful to the IFER for their support towards this goal. Thank you.